Now, in the view, we had studied about the Doppler effect. The same definition we are studying once again. The apparent change in the frequency of wave due to the relative motion between the source and the observer is called as Doppler effect. Okay. So, in the wave optics, we are studying about the Doppler shift. We are studying about the Doppler shift. So Doppler shift means it is defined as a ratio of change in the frequency to that of original frequency. So this is the change in frequency to that of original frequency. Change in frequency to the top original frequency is called as Doppler shift. Okay, and it is given by the change in frequency delta mu is divided by mu is equal to, we can write as v radian, okay, divided by the c means velocity of light, and here I am putting negative. So negative sign indicates when the source is moving towards the observer. So here d radian means radial velocity of the component of velocity source along the line joining the observer to the source relative to the observer. So here v radian means radial velocity of the component of velocity source along the line joining the observer to the source relative to the observer. So here you have to remember negative sign indicates when the source is moving towards the observer. Okay, one note point you have to remember. When this is not there, minus, instead of minus it is plus. So we can say that the radial velocity is moving away from the observer. Okay, so this is about the Doppler shift. Now in this one, what is meant by redshift? What is meant by blue shift? We have to discuss. Okay, so redshift means what? Suppose the person is here in the platform, as well as the train is also in the platform. So here observer is the person, train is the source. So when the source is moving away from the observer, what happens? There is a decrease in frequency. There is a decrease in frequency or increase in wavelength. Then it is called as redshift. When the source is moving away from the observer, there is a decrease in frequency. What is the meaning of this one? Train is there, person is there. So when the train is moving to start from the platform, it is moving away. from the platform. So what happens to the observer person? The sound will be less and length will be more. So that's why we say that the source is moving away from the observer. The source is moving away from the observer. There is a decrease in frequency or increase in wavelength. Then it is called as redshift. Okay. Next. Here, what is blue shift? What is blue shift? Blue shift means what? Means the person is in the platform, the train is somewhere, it is coming near to the platform. So what happens? With the train is the source. So the source is moving towards the observer. The source is moving towards the observer. Then what happens? There is an increase in frequency. There is an increase in frequency. Means what? The sound will be more and more when the train is coming near to the platform. So what happens? The source is moving towards the observer. There is an increase in frequency or decrease in wavelength. Then that is called as blue shift. Okay. Now, next concept is concept of superposition. Concept of superposition. Concept of superposition means what? Superposition means what? Two or more views or more than two views arrive simultaneously at one point. Then that is called as superposition. So here I am taking the view like this. So what is this one? This is the crest. This is the trough. Okay. So what I am doing is, this is nothing but amplitude named as A1, or we can assume as Y1, anything. In the similar way, another wave I am writing. Another wave I am drawing like this. So what I should write? This is the amplitude. So this is nothing but Y2. So what is the resultant displacement? So this is the individual displacement. This is also the individual displacement. So what I should write? How to draw this diagram? How to draw the figure? So crest. So what is this one? This is nothing but what? Y1. Okay. In the similar way, again this one, what I am doing? I am drawing the wave like this. So what is this one? This is nothing but Y2. So the total is what? Y is equal to Y1 plus Y2. Okay. So what is the meaning of this one? Means the resultant displacement of a wave is equal to the vector sum of individual displacements of the wave, is called as superposition. So in other way, let us suppose this is the first one. Now I am drawing like this. So this is Y1. Okay. Next, another view I am drawing like this. Like this. So this is a positive and this is a negative. This is y2. So what is the resultant displacement? So therefore the meaning is y is equal to y1 is positive and this is what? This is negative. So how to draw this both combined figures? How to draw it? I'll draw it. So this is a wave named as y1. This one like this. This is a wave y2. So this is crest, this is trough. So therefore what I should write? Y is equal to positive minus negative. Y is equal to y1 minus y2. Okay. So suppose this is A, this is also A, then what I should write? So the total will be how much? A is equal to A1 plus A2. So this is the resultant, you can see. Okay. In the same way here, this is y1, this is y2. So what happens? The resultant will be y1 minus y2. So here this is about the superposition. This is about the superposition. So from here, what we can see here, superposition means what? The resultant displacement of a wave is equal to the vector sum of individual displacement of the wave. So here what happens? y1 means y1 we got it. y2 means y2 we got it. But here what happens? y1 plus of minus y2. Plus of minus y2. So therefore, what is the meaning of this one? Minus y2. Plus of minus y2. Therefore, the meaning is minus y2. So what is the meaning of this one? Y is equal to y1 plus of minus y2. Is equal to what? Plus into minus is minus. That's why y1 minus y2. Okay. So what is the meaning of this one? They are in same phase. They are in same phase. But here what happens? They are in opposite phase. They are in opposite phase. Okay. Now here, so what is the definition? At a point in a medium, the resultant displacement at a point in the medium, a resultant displacement is equal to the vector sum of individual displacements of a wave like this and so on. Then that is called as superposition principle. Okay. So here or like this also we can write it. J is equal to what can write? A1 plus A2 plus A3 plus and so on. Like this also we can write it. Okay. Now, so what is the equation given as for the superposition of wave? So A is equal to root of A1 square plus A2 square plus 2A1 A2 cos theta. This is a formula for superposition principle. How you got it? Let us do the proof afterwards. Okay. Now, for the case 1, if theta is equal to 0, so what is the value? A is equal to root of A1 square plus A2 square plus 2A1 A2 cos 0. Cos 0 means what? 1. Therefore, what I should write? A is equal to a1 square plus a2 square plus 2a1 a2. Cos 0 means 1. So, this value we can write as a1 plus a2 whole square root. Square root cancel. What is the value? a1 plus a2. So, what we can see as the resultant displacement of a wave is maximum. So, here in place of a1 we can keep as y1 square, y2 square plus 2y1 y2 cos, like that also we can write it. So, here what I can say? J is equal to what? a1 plus a2 is nothing but maximum. So, previously I had shown the figure. With the help of the equation you are getting a is equal to a1 plus a2. Now, in case 2, if theta is equal to 180, if theta is equal to 180, so what is the value? A is equal to root of a1 square plus a2 square plus 2a1 a2 cos 180. Cos 180 kitna? How much? Minus 1. So, what is the value? Root of a1 square plus a2 square cos 180 is minus 1. So, minus 2a1 a2. So, from here, what is the value we write it as? a1 minus a2 whole square root. Square root cancel. So, from here, what we should write? A is equal to a1 minus a2. So previously we had studied it. One wave is up, second wave is downside. So one is a crust and there is trough. So there we got y is equal to y1 minus y2 or a is equal to a1 minus a2. Okay. So here they are in the same phase, they are in the opposite phase. So the resultant is displacement is maximum and the resultant displacement is minimum. So this is about the superposition principle. So you have to remember, at a point in a medium, the resultant displacement of a wave is equal to the vector sum of individual displacements of a wave. That is, y is equal to y1 plus y2 plus and so on. This is about the superposition principle. Now, how we got r is equal to root of a square a1 square plus a2 square plus 2a1 a2 cos theta. I will show the proof. So, no. Here y1 is equal to a sin omega t, what is it? y2 is equal to b sin of omega t plus phi. Okay. This I'll take as theta, anything phi. Now, superposition principle means what? The resultant displacement of a wave is equal to the vector sum of individual displacements. y1 plus. So, y is equal to a sin omega t plus b sin of omega t plus theta. So, from here, what is the meaning of this one? Y is equal to a sin omega t plus b into sin omega t cos theta plus cos omega t sin theta. So from here, what is the meaning of this one? A sin omega t plus b sin omega t cos theta plus b into cos omega t sin theta. From here, what is the meaning of this one? Y is equal to sin omega t into a plus b cos theta plus b cos omega t sin theta. Okay. So let us consider, let r cos phi is equal to, I am writing as a plus b cos theta, and here in this one r sin phi is equal to b sin theta, b sin theta. Now what I am doing is squaring on both sides. So squaring on both sides. So what I should write? R square cos square phi is equal to a plus b cos theta whole square. R sin phi means what? R square sin square phi is equal to b sin theta whole square. B sin theta whole square. So now what is the value we can get? Squaring on both sides. Now what I am doing is I should add. So r square cos square theta plus r square sin square theta is equal to, what I should write? A plus b cos theta whole square plus, what I should write? B sin theta whole square. B sin theta whole square. So now if I take common, r square cos square theta plus sin square theta is equal to, what I should write? A square plus b square cos square theta plus 2ab cos theta plus b square sin square theta. Here cos square theta plus sin square theta is equal to 1. So what I should write? R square is equal to a square plus b square cos square theta plus sin square theta plus 2ab cos theta. So here cos square theta plus sin square theta is what? 1. So here r square is equal to a square plus b square plus 2ab cos theta. So what I should write? R is equal to root of a square plus b square plus 2ab cos theta. So this is the formula how we got it. This is the resultant displacement of a wave. Now we know that intensity of a light is directly proportional to the square of the amplitude. Square of the amplitude, or this can be written as intensity is directly proportional to the square of the amplitude, or in terms of R also we can write it. So here what is the meaning of this one? I is equal to k into r square. I is equal to k into r square. So what I should write? I is equal to k into r square means what? Root of a square plus b square plus 2ab cos theta. This is whole square. So what is the meaning of this one? Square root cancel. Square root cancel. So what is the value you should write now? What is the value? So here the meaning is I is equal to ka square plus kb square plus 2ab k cos theta. K is a constant. K is a constant. So here what is meant by Ka square? Here we are studying. Here what we are studying? Intensity is equal to directly proportional to square of the amplitude. If I write like this, so what is the meaning of this one? I1 is equal to Ka square. I1 is equal to Ka square. So I is equal to, I can write as I1. This can be written as I2. Okay. I1 is equal to Ka square. I2 is equal to what? Kb square. Right. Now here, what is there here? AB is there. AB is there. So if I take this one, what I should write from here? A is equal to root of I1. K is a constant. Nothing but you can assume as 1. In the same way, B is equal to root of I2. B is equal to root of I2. So this equation we can write as plus 2 into A means what? I1. B means what? Root I2. Here where is K is there? K is a constant. Here what is there? Constant. So constant. So this is the resultant intensity formula. So we had studied two formulas. One is what? R is equal to root of A square plus B square plus 2AB cos theta. Very, very important formula. Okay. Another formula is what? Intensity. I is equal to I1 plus I2 plus 2 is root of I1 I2 cos theta. These two formulas are important for the competitive also. Okay. So this is a note point which you have to remember. Next topic, we are studying about the coherent sources of light. Coherent source of light. Coherent source. Okay, means what? Two sources, two or more any sources. Two sources emit waves of same frequency with zero phase difference or constant phase difference, then it is called as coherent source. So two sources emit waves of same frequency with zero phase difference or constant phase difference, then it is called as coherent source of light. So what is the meaning of that? Means, suppose I am drawing the wavelengths. Okay, like this. So this is a wall, nothing but screen. Okay. So now what I am doing is I am drawing another view like this. So what is the meaning of this one? Constant phase difference or zero phase difference, same amplitude. Okay. Then this is called as coherent source of light. Understood? Suppose another figure I wrote. And here we can say that same frequency or same wavelength also. So same wavelength means what? This is the crest, this is the crest. The distance between the two crest or two trough is nothing but lambda. Okay. In other figure, then also we can say that it is a coherent source of light. How? Suppose this is a wave like this. This is the source of light like this. Okay. Now here what happens? Here I am drawing like this with the blue color like this. So here also what happens? Zero phase difference, zero phase difference. Then also it is nothing but what? Coherent source of light. The distance between these two waves is nothing, two crests is nothing but what? Lambda. So that's why two sources emit waves of same frequency with a zero phase difference or constant phase difference, same wavelength, then that is nothing but what? Coherent sources. Okay. Now, what is the meaning of incoherent source of light? Incoherent source of light. So next is incoherent source of light. So incoherent source of light means what? Two sources of light having the same frequency or different frequencies. Having the same frequency or different frequency. But it is not having the stable phase difference. Then that is called as incoherent source of light. So here I am writing the sentence. Sources of light are two sources of light having same frequency or different frequency or having different frequency and not having stable phase difference. Not having stable phase difference and not having stable phase difference is called as incoherent source of light. So what is the meaning of this one? The wave is passing like this, up to here, right? Another wave, it starts like the same thing, but it stops up to here. Means what is the meaning of this one? It is not having stable phase difference. It is not having the stable phase difference. Therefore, that is nothing but what? Incoherent source of light. So where it occurs? So what is the example? So we can take that ordinary light, nothing but tungsten filament. Tungsten filament. For the coherent source of light, what is the example? Sodium lamp. There everything is same. But here in the tungsten filament, what happens? One ray will be shorter, one ray will be longer. So for the example, for the incoherent source of light is tungsten filament, and for the coherent source of light, sodium lamp. Okay, these are the coherent sources as well as incoherent sources. So you have to remember, coherent source of light means what? Two sources of light having the same frequency or having the same wavelength with zero phase difference or stable phase difference or constant phase difference, then that is called as coherent source of light. Incoherent source of light means what? The two sources of light having same frequency or different frequency, having same frequency or different frequency, and it is not having the stable constant phase difference. It is not having the stable constant phase difference. Not having the stable phase difference. Then that is called as what? Incoherent source of light. Okay. So you have to remember the coherent source as well as incoherent source. They last for 1 mark definitions.